The link, as always. Here's the link. I'll share it in Telegram and we can start. Perfect. Paul, do you want to start?
Yeah, sure. So I've been working mostly on two things, on the OpenAPI specs implementation and on continuing building the process execution payload core internal function. For the OpenAPI specs, I'm working just on adding the specification and understanding better how it helps with the input validation. And for the process execution, I'm having problems with how we manage the types internally, because basically to be able to send them through the network, we need to encode the things differently than the way we encode them locally. As Thomas pointed out, a document that I didn't have before, we everything is hex encoded. So the integers are hex encoded, and the binaries are also base 16 encoded and entered into hex. So yeah, basically we prefix everything with 0x and we base 16 it. So I'm working on that right now to be able to do that with the execution payload. I'm also after going to look if we need to generalize that. If yes, then I'll create a specific function that can potentially take any type of struct, turn it into a map, and then go through each of the key value pairs for the fields and turn that into correctly formatted hex string before sending it through the wire. Or if it's not useful, because for example the only method where we actually send uh, elixir type is this method, then I guess I'll leave it manually implemented specifically in this method. So working on that, and I saw that Thomas has implemented the list serialization and deserialization. So I'm waiting for the merging of that to update my main and start merging it into my PR and starting deserializing and serializing lists to finalize the tests. That's
Okay,
why.
that's cool. Yeah. Let us know if you have any more troubles with binary serialization for JSON format. I do understand that that's very different to the other kinds of serialization we've been doing now until now, which is SSZ. So, like, feel free to just keep asking questions, and that's great. I fully expect us to have more bumps on the road with this kind of stuff, so don't worry about that. We are here to help. But yeah, great progress on that.
Yeah,
Tomas?
thank
Oh,
you very
sorry.
much. No, I just wanted to say thank you for the help.
Of
Because
course.
indeed it's true that we're using like a lot of serialization, deserialization, and a little bit everywhere, because we have our
Yeah.
own internal representation, which is different from the representation of Rust, which is different from the representation of the NIF, which is different from the representation of the data that we need to send over the wire of the engine API, which is different from the internal representation of the execution client. So there's a lot of things that we need to take into account, and yeah. But yeah, thank you for the help, and I think it should be all right pretty soon.
Yeah, integrating with other systems always feels like that. But we will. It's just a bump on the road, and we'll get over that without any issues. Tomas, you want to go next?
Sure. Actually, about the list serializing, I modified a bit of the code in the PR. I made a little refactor, reduced the duplication of a lot of duplication in the functions. Hopefully that will help us in adding more composite types. Yeah. Yeah, that's what I was mostly working on. Also thinking about different ways we could refactor it to uh, reduce the amount of work we need to add new types. Hopefully, stop hard coding each one of them. Uh, yeah. Well. Yeah. Well, we sorry. We still have to discuss the way to which way we want to go with the NIF. For now, I think we can just go with your idea, Thomas, about adding a new entry point for the NIF for each one of the entry points, for each one of the composite types. With for now, with list and vector, I think we got enough. We got enough. I'll work on that. Try to finish the PR about list realization. I don't think it will take me much time now that the refactor is done. It simplifies a lot of the macros. You previously had to declare all the types we were exporting in each of the entry points of the NIF, and I reduced that so that you have to list it inside of a macro, just in one place. So now we can more easily add one new entry point for the NIF, and with that it should be a piece of cake. Later I'll work on adding the support for the vectors. Yeah, with that, later we can discuss if we need another refactor or. Well, that's all.
Awesome. Yeah. On the one hand, I'm really glad that we got the list and vector types in. That's perfect. Thinking some ideas for the refactor is great as well, but I wouldn't take that much time on that. For instance, if that takes today, that's great, and we can then maybe tomorrow have a discussion on that. But after today, I would go back to focusing on how's this called, the checkpoint sync, getting the blocks after the ones from the checkpoint. I think that's the part that we should focus on next, so that yeah, so that we go back to the milestone instead of refactor. Because I'm all in favor of having refactors here, but probably those are not the most prioritary. Like and even at some point we will have our own SSZ implementation, so I wouldn't put all our energy into building like the best possible SSZ NIF interface for this library, because eventually we'll have our own. So and also this doesn't negate anything that you just said. Like having less code duplication is awesome, having macros is awesome, but I wouldn't spend like 2 or 3 days in getting like the best ideas for refactors, which I think that you're going to do, but just so that you know what's the time that probably should focus on.
Yeah,
Yeah,
no,
I think that's it.
the thing was. No, the refactor was this simple like thing to reduce the amount of code we needed for each new entry point. I have some ideas about how to help on the transition, on the future transition from the NIF to our own implementation. But I just wrote it down and it's for later discussion. As I said,
perfect. Having that document is awesome.
I'll add just the support for these two composite types and then return to the checkpoint sync work.
Awesome. Glad to hear that. Do you have anything else?
No, that's all.
I had a question.
Perfect. As for me, I don't have many updates, like coding updates, unfortunately. I've been finishing the review on the bootcamp applications. I will be finishing that definitely today, and we'll be publishing results as soon as I can. But that would be at some point today. So yeah, I'm giving it my 100% right now. So I should be finishing very soon.
Super cool.
And that's it. After I finish with that, I will go back to reviewing PRs. Sorry for the delay on those, but as I will finish the other task today, I will get back to reviewing PRs today as well.
Super cool. I had a question about
Yeah.
ports and NIFs. My understanding is that the ports will replace the NIFs, right? The ports will be the interface for us.
Not all the NIFs. I mean,
Okay.
we'll at some point, the strategy is to move specifically libp2p and like in general gossip protocol to ports. And the reason for that is that libp2p has a lot of blocking operations, and NIFs are not well designed to handle blocking operations. They are not even well designed for very long operations, more than 1 or 10 milliseconds. There's dirty schedulers for that, but dirty schedulers are very limited if you have several threads with them, or Go processes in the sorry, not Go. That was a bad one. Elixir processes. But the point here is that NIFs were exactly designed for stuff like our interface with SSZ or with other libraries. That's just a function call. So until we create our own SSZ library, we will keep using NIFs for that one, because it wouldn't make sense to use ports on that specific case. It would be actually very inefficient and wouldn't have any clear advantage. We are definitely still, but the idea is at some point, maybe milestone 2, have libp2p move to ports if we have enough slack time after implementing all of the features for milestone 2. I don't remember if we have a third NIF somewhere else. Did we?
The BLS.
Yeah.
That one.
BLS is also likely to keep being a NIF. Even when Lambda Works people implement BLS, they will implement it in Rust so that we will have a NIF to Rust as well.
There's also the
even if yeah.
There's also the Snappy. There's
Yep.
BLS, libp2p, Snappy, and SSDNIF.
Awesome. Yeah, thanks for the list. Effectively, like all of those will still be NIFs, because those are like typical NIF use cases, which is calling some things that are either more available in other languages and you still didn't get to implement them, or they are more efficient in other languages. Because this is a very long discussion, but Elixir is great for keeping high levels of concurrency with a predictable result, and that's one of the reasons why it's better than many other languages in backend solutions. But it's not the great in batch computing. Like, for instance, you need to calculate the hash of 200 things, or you need to make a query in a table with, like, I don't know, 100,000 elements. So typically, you delegate those to something that's implemented in another language. That's more efficient with that kind of operations. But yeah, I think that's it. Any other comments or questions? Okay, I'll take that as a no. We can finish the daily for today. Thank you all for joining, and see you all tomorrow.